This is lesson 2.2, solving equations with variables on both sides of the equation. In this lesson, you'll learn how to solve a linear equation with variables on both sides of the equation. Hey. So there's an example up there at the top. This is what about 2m plus m equals 6m plus 4. Do you see how you have variables on both sides of the equation? Before we get into it, let's review again how we combine our like terms. Go ahead and solve these three problems here, not solve them, sorry, simplify them. We can't solve because there's no equal sign, correct? Alright, so write the like terms in each expression or equation. Well, the like terms in the first problem are the positive 5x and the positive 2x. If you identify your terms before you do this, it makes it a whole lot easier to identify your like terms. Let's look in problem number 2. Is that an expression or equation in problem 2? Well, just like problem number 1, it's an expression because there's no equal sign. Let's go ahead and identify our variable terms and our constants so that we can figure out what our like terms are. 1.5y, yeah, just because your coefficient is a decimal doesn't change anything. It's still the coefficient of the y, so that is a variable term. Negative 1.2 is a constant. Positive 1.2z is a variable term. And positive y is a variable term. Now, one thing I notice here, though, our variables are different. Remember, like terms have to have the same variable. So even though I see 3 circles, not all of those circles are like. In order for them to be like term, they have to have the same variable. So that means this positive 1.5y and this positive y over here, those are really the only 2 like terms here. So 1.5y and y are the like terms in problem 2. Problem 3, again, let's identify our terms. We have a 1/2 x. 1/2 x, we have a fraction in front of a variable. It's the same thing as beside it and under it. So there we go. There's our variable term. Positive 1/2 is a constant. And 3x is a variable term. So this one we can clearly see that our like terms are the 1/2 x and the 3x. Right. So you are going to have to be able to identify like terms in expressions or equations. Let's look at our first focus question here. First step, cross multiply any complex fractions. Hopefully by the time we're done here you'll know all 6 of these steps and you can just start saying them in order. Maybe on the next problem I'll cover them up and then you tell me what's the first step, what the second step is. So first step, cross multiply complex fractions. Do we need to do that here? No, there's no complex fractions on this problem. And really they're not that common, but I just need to tell you that if you do have them, that is the first step you will always do on any linear equation. Next step, distribute. Do we need to distribute in this problem here? No, we only distribute when we have parentheses. Step 3, identify the terms. This is the one step that I always say you can never get away from, and don't ever skip it. I know some people just like, I want to take my training wheels off. I think I can just do this in my head. If you ever get stuck and you don't know what you're doing, put your training wheels on and then you'll figure it out. 11 is a constant. Negative 8n is a variable term. 1 is a constant. And negative 3n is a variable term. So we've identified our terms. Step 4, we're ready to combine our like terms. Now what makes this problem different from our previous problems is we not only have constants that we need to combine, we also have variable terms that we need to combine. And just like our constants, in order to get them on the same side of the equation as one another, you have to change the sign to make that 0 pair to be able to move it. Now when you have variables on both sides of the equation, if you're like just looking at your constants, like, well, which way do I go? There's a variable on both sides. How do I get the variable all by itself? And how do I get the constant all variable by itself? Here's my rule of thumb. Put your circles on the left and your squares on the right. So we want all of our circles to be on the left-hand side of the equation and all our squares to be on the right-hand side of the equation so that we can combine them together. So looking at the positive 11, is it going to stay where it is, or do we need to move it? It's a square, and it's currently on the left-hand side of the equation. We want it to be on the right-hand side of the equation. So we need to move it. So you change its sign. And whatever you do to one side, you do to the other. Now, where do I put it, though? I know I need to go move it to the other side, but let's put it with our other constant, or right underneath our other constant, instead of under the negative 3n, underneath the other constant that we know that eventually we need to combine it with. I'm going to draw a line. Now I'm not done yet because I still need to get all my circles on the left and all my squares on the right. So this is what's different here. I have a negative 8n and a positive 3n. I need to get those circles together, on the same side together. I need to move one of those to the left-hand side of the equation. Which one is that? Yeah, the negative 3n. So just like the constants where I had to change the sign, I need to do that with a whole variable term. So I write positive 3n so that I can get rid of it from this side of the equation, but I need to move it over here with the other side of the equation as positive 3n. Okay, so now I have all my circles on my left and my squares on my right, or my variable terms on the left-hand side of the equation and my constants on the right-hand side of the equation. Once I do that, I can draw my big fat line and I'm ready to combine. I combine my variable terms just like in the previous lesson. We just combine their coefficients together using the SOB rule. So negative 8 and positive 3, those are opposite signs, so we have to subtract. 8 minus 3 is 5, but the bigger sign wins, so it's a negative 5. And the n just carries down, it doesn't change at all. It's like saying, oh, I have negative 8 napkins plus 3 napkins equals negative 5 napkins. Equals. Now I need to combine the 1 with the negative 11. Those are opposite signs, so I have to subtract. 11 minus 1 is 10, but the bigger sign wins again. So don't forget the b, and bigger sign wins. It's a negative 10. So I've finished combining my like terms. Now I need to isolate my variable from its coefficient. See, I've got just one circle, one square. I have a negative 5 that's beside my n, so what do I have to do? If it's beside it, I have to divide it. Divide by negative 5. Don't draw your line all the way across, and make sure that you keep the sign. That's a negative 5, so I divide by negative 5. It's not changing the sign, because I'm not combining like terms, I'm isolating. So n is equal to negative 10 divided by negative 5. Well, negative divided by negative is a positive. 10 divided by 5 is 2. So n is equal to 2. So I did my C, D, I, C, I, C. I'm ready to check. I'm just going to change colors. I think I have enough room to check this, maybe. 11 minus 8 times n, which we said is 2, is equal to 1 minus 3 times n again, which we said is 2. Alright, before when we checked our problems, we always had just one number on one side of the equation. So we have an expression on the left-hand side and the right-hand side. You need to simplify those separately. Change my pen color back in. So I'm just going to look on one side. I am going to erase, sorry. I'm going to erase so I can have room to show you this. So we said our answer is n is equal to 2. There we go. But we need to use our order of operations to check this. So I'm going to look just on the left-hand side of the equation. I have 11 minus 8 times n, or 8 times 2. I need to do my multiplication first. So I have 11, negative 8 times a positive 2 equals a negative 16. 11, take away 16. Oh, it's a subtraction, so I need to keep, change. A negative, or a positive 11 and a negative 16 are opposite signs, so I need to subtract. 16 minus 11 is 5, but the bigger sign wins, so it's a negative 5. So all that on the left-hand side is equal to negative 5. Now let's look at the right-hand side of the equation. On the right-hand side, you have 1 minus 3 times n, which we said n is 2. So it's really 1 minus 3 times 2. We have to do our multiplication first. So we have 1, it's a negative 3 times a positive 2 equals a negative 6. Or you can think of it as 1 minus 3 times 2. 3 times 2 is 6. Means the same thing. 1 minus 6, again, it's a subtraction, so I need to keep, change. I have a positive 1 and a negative 6 equals a negative 5. There we go, it checks. So my solution was n is equal to 2, and we plugged it back in and it checked. Yeah, these multi-step equations, if they're multiple steps, they're going to take some time. Just work slowly and carefully. Watch those signs. Right, do one more example with you. Oh, I said I was going to cover up our steps here. Ooh, so you had a little quick peek at them. Alright, what are our 6 steps? Let's just write our letters down. What's the 6 steps to help you remember? C, D, I, C, I, C. Okay, so our first step, we need to do what? Cross multiply complex fractions. So do we have any here? Nope. So we're done with that step. Alright, what does the D stand for? Distribute, if you have parentheses. Do we need to distribute in this problem? Nope. What does the I stand for? C, D, I. Identify. So let's go ahead and do that. This is the step we don't skip. 2m is a variable term. Negative 6 is a constant. Negative 6 is a variable term. Oops, I just about wrote a square there. Negative 3m is a variable term. And negative 2 is a constant. So we've identified our terms. We're ready for the next step, which is to, what does C stand for? Combine like terms with the SOB. Okay, so this is the step that takes a little bit of time. Let's check each one of our terms and decide if it's going to stay, then don't write anything underneath it. But if it's got to go, then write its 0 pair. 2m, is it going to stay or is it going to go? It's a variable term, so it's going to stay because we want our variables on the left and our squares on our constants on the right. Negative 6, is it going to stay or is it going to go? It needs to go. So write positive 6 underneath it to make that 0 pair. But make sure that we put the positive 6 underneath the other constant on the other side of the equation. How about the negative 6m? Is it going to stay or is it going to go? It's going to stay because it's a variable term. We want it on the left. How about the negative 3m? It needs to go. It needs to go to the right hand side of the equation, so we need to write its 0 pair as positive 3m. Now, where you write it on the other side of the equation really doesn't matter because we have 2 of them. I'm going to go ahead and write it underneath the other positive variable term. So the positive 3m under the 2m. You'll see why here in just a minute. So there's that 0 pair, and the negative 2 needs to stay. So now I'm ready to draw my big fat line and combine. On the left-hand side, you have the 2m, the negative 6m, and the positive 3m. We need to combine all three of those variable terms together. Now, the reason why I put the positive 3m underneath the 2m, because I just think it's easier to, if it's already the same sign, so you can add those two together first, and then subtract the 6. So 2 plus 3 is 5. So we got a 5m when we combine those two together, which is still a variable that we need to combine with the other variable term of the negative 6m. That's opposite signs, so you have to subtract. 6 minus 5 is 1m, but the bigger sign wins, so it's a negative 1m. Is equal to, and we combine the constants on the right hand side of the equation. Negative 2 and positive 6, those are opposite signs, so you have to subtract. 6 minus 2 is 4, and the bigger sign wins. 6 is bigger, and it's positive, so it stays positive. So we're done with combining our like terms. What's the next step? Starts with an I. Isolate the variable. So we have what numbers with our variable right now? Negative 1, and it's beside it, so we have to divide it. We divide by what? Negative 1. Remember, when you're isolating your variable, you do not change the sign. So m is equal to 4 divided by negative 1. A positive divided by a negative is always a negative, and 4 divided by 1 is 4. Don't say 0 or 1. I see weird answers like that all the time. So there's our solution that we think it is. M is equal to negative 4. We're done with step 5. What's step 6? Yeah, the one that everybody hates. Check. But it's so worth it. Because if you ever check your answer and you get something different or something that's not equal true, then we know you made an error and you can go back and do it. If you don't check it, you won't know that you missed the problem. So we said the answer is negative 4. I'm going to erase so that I can check the problem. So I have 2 times m, which is negative 4, minus 6 times m, which is negative 4, is equal to, I tell you what, because I have such little room, I'm going to do just the left-hand side of the equation in purple, and I will do just the right-hand side of the equation in blue, and then we'll check to see if they're the same number. So I'm just going to simplify just the left-hand side of the equation. I use my order of operations because it's all numeric now. I need to do my multiplication first. So I have 2 times negative 4 is negative 8, and I have negative 6 times negative 4 equals a positive 24, and this 6 right here just comes straight down, so negative 6. Oh, I need to write the positive 24 because it's not the first term in my expression. Now I have a negative 8 minus 6 plus 24. What do I need to do next? This is one of the most common places where people mess up. They will do this. They'll do, 6 plus 24. Because, in order of operations, please excuse my dear Aunt Sally, A comes before S. But what do we need to remember about addition and subtraction? We always do it from left to right, regardless of if it's a addition or subtraction. So I need to first do the negative 8 minus 6. Oh, it's a keep, change. Keep my negative 8, change it to plus, and make it a negative 6. A negative plus a negative equals a negative, because the bigger sign's 8, but they're the same sign, so I need to add the 8 plus 6 is 14, and then just bring down the 24. Oops, sorry, I didn't mean to do that in blue because I said I was going to do the other side of the equation in blue. So what would we say, negative 14 plus 24, because we're still working on the left-hand side of the equation. And negative 14 and positive 24 are opposite signs, so you have to subtract. But the bigger sign wins, so you get a positive 10. Alright, let's look at the left-hand side of the equation now. Again, I'm going to switch to my blue pen. So I'm looking at the negative, this part right here, negative 3m minus 2. Let me copy it down. Negative 3 times m, we said m is equal to negative 4, minus 2. What am I trying to do? My goal here at this point, or what I want to happen, is simplify this and get 10 so that I can check it with their left-hand side. So negative 3 times negative 4. Those are the same, or no, wrong rule. Multiplication, remember we use our negative and a negative equals a positive, yeah. So positive 3 times 4 is 12, minus 2 is equal to 10. Yes, 10 does equal 10. So our solution is correct. We did it. Alright, last example with you before you go to your guided practice. Alright, and I've already put up all the steps for you, but you do need to start memorizing these steps in order. Cross multiply complex fractions, we don't have any. Distribute, oh, we do have distribution in this problem. What are we distributing? The negative 4. Don't forget that sign there. We need to distribute to every term inside that parentheses. So I'm going to copy down from left to right. Negative 3. Now I'm ready to multiply. Negative 4 times positive 6a. A negative times a positive equals a negative. 4 times 6 is 24. A. I'm going to write a little smaller here for you, just a second. Here we go, that'll give me some more room here. Negative 4 times positive 3 equals negative 12 is equal to, and on the other side I just copy things down, 19, 7a. So I've finished distributing. Now I need to identify. Negative 3 is a constant. You have a variable term, a constant, and a variable term. So under which terms do I need to write a zero pair for? I need a zero pair underneath the negative 3 because it's a constant. We want it on the right-hand side of the equation. So I'm going to write it underneath the other constant that's already on the right-hand side. The negative 24a is going to stay because it's a variable term. I want that variable on the left-hand side. The negative 12 is a constant. I do not want it on the left-hand side, so I need to write a positive 12. And I'm going to write the positive 12 on the other side underneath the other constant. The 19, the 3, and the 12, those are all constants, so they stay put where they're at. The negative 7a, though, is a variable term, and I want that on my left-hand side of the equation, so that has to go. I make it a zero pair, positive 7a, and I make sure to write the same positive 7a underneath the variable term on the other side of the equation. I draw my great big line, and I'm ready to combine. When I combine, I use SOB, so negative 24 and positive 7, those are opposite signs. I have to subtract. 24 minus 7 is 17, but the bigger sign wins. 24 is bigger and it's negative. And I need to then copy down the a. Don't forget your variable, it doesn't go away. Then bring down my equal sign. Don't forget your equal sign too when you combine things. I see that all the time. And then everybody gets lost because they forget which side of the equation they're on. So they forgot to copy down the equal sign directly below it. Alright, now we have a 19, a 3, and a 12 that we need to combine all together. Those are all the same signs, so that shouldn't be too bad. So we need to combine all three of those numbers together. I would probably, I maybe would group my 3 with my 12 because I know that 3 and 12 is 15. And then add my 15 to my 19. You can go any direction you would like, but I don't know why that seems easier to me. So 15 plus 19 is, so that's 15. 9 plus 5 is 14. Carry my 1 is 34. Yeah, that's a lot of mess there. It does come out to 34, I believe, but if not, then I'll be able to find out when I check my problem. So I've just finished finally combining like terms. Oops. I'm done combining my like terms. Now I need to isolate the variable. I have a negative 17 beside my variable, so I have to divide it. Beside it, divide it. So I divide by negative 17. The sign does not change. So A is equal to whatever 34 divided by 17 is. Does that come out even? It does. 34 divided by 17, if you use your calculator, I don't care, is 2. Positive divided by a negative equals a negative 2, though. So we get A is equal to negative 2. We believe that's our solution. I'm going to write this down over here and get set up to check. Alright, so I'm going to copy down the problem. Negative 3 minus 4 times 6a, that's where my variable is going to go, plus 3. I'm just going to copy it all down, except for I'm going to leave some holes for my variables. A set of parentheses every time I have a variable to plug in. And inside that hole I need to plug in the solution that I got of negative 2 to check to see if it works. Alright, okay, I think I can, if I write small enough, I can do the problem instead of the way I did it last time. So I need to do what's inside parentheses first. I'm going to just copy everything else around it. 6 times negative 2 is negative 12 plus 3. But I am just going to work on one side of the equation before I go back and start working on the other, simplifying it. So I have negative 3 minus 4, negative 12 plus 3 is opposite sign, so I have to subtract. It's negative 9. I need to do my multiplication next, right here, so I copy down the negative 3. I have a negative 4 times a negative 9 equals a positive. 4 times 9 is 36. Almost done here. Negative 3 plus 36, those are opposite signs, so you have to subtract. 36 take away 3 is 33. And the bigger sign wins, so it stays 33. So I get 33 on the left-hand side of my equation. Now I'm going to work on focus on simplifying the right-hand side of the equation and hope that I get a positive 33 again. So I get 19. I have to do this multiplication first. So I have negative 7 times negative 2. A negative times a negative is a positive. 7 times 2 is 14. So then I just add my 19 plus my 14 together. 9 plus 4 is 13. Carry my 1 is 33. I did it. I got 33. So it checks. Didn't make any mistakes that time. Alright. Go ahead and complete, check, and correct now your 2.2 guided practice before you do your homework for both lessons 2.1 and 2.2. Good luck.